A dark rye bread dotted with small black grains. Ergot, a fungus that can burn the limbs and trouble the mind. A Victorian candy, an almost fluorescent green, beautiful but sometimes laced with arsenic. A street pump, its clear water dripping slowly. But transparency is no guarantee. And now, I invite you to open the pantry of the past. For centuries, water was the primary risk. Wells too close to cesspits, shared buckets, pipes that drew in wastewater. You can't see a thing, and therein lies the danger. So people drank weak beer or watered-down wine. To boil and ferment was already a form of purification. Lead glazes, when exposed to acidic foods, would leach metal. Old pewter wasn't always safe. Here, the material is as important as the recipe. Vinegar, broth, and macerated fruits all have different effects on the dinnerware. Without refrigeration, preservation becomes a risky art. Salt protects meat and fish unless the brine goes bad. Smoking helps, but the lack of air can allow a silent toxin to thrive. At summer markets, fish would heat up and become true poisons. But I assure you, madam, this fish is excellent. Look how it shines. Go on, make an effort. Near the outlets, the estuary both nourishes and sometimes poisons the shellfish. Then there's the fraud that's all too obvious. At the dairy, milk turns sour. Some add water and chalk, or later, formaldehyde to mask the odor. Pleasing to the eye, but false on the tongue. These peas, a brilliant green in the dead of winter, were intentionally dyed with copper salts to look fresh. In the bakery, alum was used to whiten bread. Ingested repeatedly, this aluminum salt would strain the stomach and intestines. In the 19th century, arsenic was used to brighten the color of candies and pastilles, leading to cases of poisoning. Even without fraud, dangers remained hidden within nature itself. Grains provide nourishment, but rye stored improperly in damp granaries could develop ergot, a toxic fungus. Undercooked meat can still harbor invisible parasites. Edible and dangerous mushrooms look alike. A simple mix-up is all it takes. Jams that aren't cooked enough will ferment. To avoid all this, simple solutions were invented. Vinegar, well-sealed jars, barrels flamed with sulfur. But the turning point comes later, when proof becomes method. Cities mapped fevers, a pump, a street, a neighborhood, and suddenly, dots on a map made it possible to identify the origin of diseases. Countertop chemistry became analytical chemistry. We search, we measure, we compare. In kitchens and factories, appertization, from the 19th century, allowed food to be preserved by heating it in airtight jars. It's effective if sterilization is controlled, but dangerous when the jars are poorly sealed and bulge. Milk, heated to the right temperature, keeps better. Anti-adulteration laws, that is, anti-fraud laws, extended from markets to workshops. Gradually, trust shifted from appearance to being rooted in procedures. So what does this journey teach us? That safety isn't something you see, it's something you measure and practice. 4 factors make the difference: heat, duration, materials, and separation from contaminants. A clear brine can be deceiving, and so can a brightly colored candy. However, a simple dish, boiled, rather acidic, served in inert dinnerware, is often safer than it appears. Our modern standards, drinking water, inert dinnerware, dates, labeling, are achievements born from accidents, investigations, and laws. Food speaks as much to our vulnerability as to our ingenuity. Behind every safe pot, there is a documented failure, a written rule, or an artisan adjusting their craft. If you enjoyed this journey, we'll put the lid back on whenever you like. In that case, subscribe. Here, we simply tell stories of what life was like before.